Hi everyone. Well, my recent video on the construction retaining wall collapse in Vancouver area of Canada got a lot of interest and got a lot of engagement. I really appreciate those of you who commented, and in particular those of you who reached out and communicated with me directly, sent me photos. Deanne, Mark, Samuel, and others, thank you very much. You'll see some photos that I was sent featured in this video. So I wanted to give an update. More information has come out about the issues associated with this retaining wall, but also I wanted to incorporate a lot of your comments. There were several themes in these comments that were left in the previous video. So if you haven't seen that video, you could check it out. I'll put a link in the description. So first of all, too, I've got a different video footage for the retaining wall collapse that I want to show you. It's a little bit clearer than what I had previously. So let's roll that. Now, again, in this video, I'm going to give you an overview of the current situation at this job site, tell you what I think the main issues are, and what the implications are for this type of construction going forward. So we can see from this photo here that the site has been temporarily backfilled, and that is to stabilize the site. This construction site is located at the intersection of North Road and Foster Avenue. The failure occurred on the Foster Avenue side of the excavation. For those of you new to this topic, the retaining wall failure was at a high-end development, a 40-story residential building that obviously involves underground excavation so that later they can build the permanent walls, and the below-grade portion will be used presumably for parking. I believe in Canada they call them parkades. So that's typical construction in the area for high-rises, is that you have the underground parking and then above-ground commercial and residential space. So this just shows you the overall project location, and now the specific location. The developer for this project is Amicon. It's a local to the Vancouver area developer and construction firm. They're quite big, and they're known for really high-end development projects. Now again, some of you reached out to me, and I received this picture of a nearby construction site, and there's some interesting elements to this photo. First of all, you can see the depth of the excavations is not unlike what we saw at the collapse site, and look how close adjacent houses are to this excavation. That would make me extremely nervous if I was a homeowner in that area adjacent to that excavation site, particularly in light of what happened at a nearby site here that we saw the collapse for. So I posed the question in my previous video, or the observation, that I thought this type of anchorage system with soil nails and a shotcrete facing was rather minimal and atypical for the types of support for excavations that I'm familiar with, even for so-called temporary excavations. A number of you reached out and told me that this is in fact quite common in the Vancouver area, and these are the photos that indicate that is exactly the case. And the depth of this particular excavation looks very similar to the one that had the collapse here recently. So I'll just run through a few of these pictures. This picture shows you the top-down nature of this type of construction. You can see that the wall is built, again, from the top down. The contractor will excavate one level. They'll provide the soil anchors, mesh, reinforcing, and then the shotcrete facing. And then they'll excavate down another level and repeat the process until they get to the full depth of the excavation. And then they would have room to build their permanent walls. But again, I'm really impressed with the height of these walls. And jumping back to the site where the failure occurred at North Road and Foster Avenue, this is a Google Street View of the project site prior to the collapse. You know, some months probably prior to the collapse, and you could see the logo on the side of the truck for a shotcreting firm. So the city of Coquitlam issued a statement about this wall collapse on their city website. So they summarize that this collapse occurred on Wednesday, November 29th, and they immediately began emergency efforts, that is through the developer, to shore the wall to ensure no further failures. Again, this failure occurred on this excavation side that was immediately adjacent to Foster Avenue that was open to traffic. Foster Avenue has since been closed to traffic. And as you saw from the earlier photos, they've placed a temporary backfill just to stabilize the excavation, and in part because they were expecting heavy rains in the area. So to me, this is the most important part of the city's statement, and I'll just read it here. It is important to note that a shoring wall is a temporary wall installed during excavation and is not the permanent foundation wall for the building, which would be subject to the BC Building Code and city oversight. The BC Building Code does not govern the shoring system. This is within the mandate of the site's geotechnical engineers, who have their own high standards and code of ethics to ensure safety in these situations. As an added precaution on this building site, the city of Coquitlam has taken the extra step of requiring the developer to hire a third-party geotechnical engineer to provide oversight of the remediation work. While this is not standard practice, city officials felt it was important to ensure that there was additional oversight and trust for the protection of city infrastructure as well as the surrounding neighborhood. So that's quite interesting. A number of you commented that you were surprised that inspections hadn't uncovered any potential problems with this wall prior to collapse. So to the extent that there were inspections, that would have been done through firms retained by the developer, associated with either an independent inspection party or those inspection staff associated with the designers of this retention wall system. Another interesting thing about this statement is it indicates that the third-party geotechnical engineer was brought in to ensure that the site was stable and that the remediation efforts would be appropriate. And it doesn't indicate that this third-party engineer will also investigate and provide findings as to the factors that led up to this wall collapse. This is contrary to earlier reports that indicated that such an investigation would in fact be performed. Now I'll roll this segment for you. That was an interview of the mayor of Coquitlam that again suggested that there would be an independent investigation performed as to the causes of this collapse.
Thursday night, Coquitlam Mayor Richard Stewart was on scene.
That stuff that isn't supposed to happen, and for it to happen on a site here in Coquitlam, we had lots of questions. I had lots of questions for Amacon, for the developer.
Amacon has plans to build a 40-story tower on the site. They said in a release there was a shoring failure and that the cause is currently under investigation, adding that all work on site had attained the required permits and was thoroughly vetted and monitored by the geotechnical and engineering consultants. No injuries occurred and WorkSafe has been on site and has expressed no concern regarding site safety.
Now, some of you have commented that, in your view, this wall collapse could have been related to improper or low-quality construction methods, and apparently that's been some point of discussion in the region for quite some time. Here's a Reddit thread that talks about this topic. So if that's a factor here in some of these projects, it could be related to the overall shortage of qualified construction contractors and staff. You know, we have this issue in the United States. I'm involved with construction phase testing of bridge foundations, and my clients are predominantly contractors, and they routinely talk about how many open positions they have that they can't even possibly fill. And they're having trouble recruiting and retaining staff for these types of jobs. And here in the United States anyway, and maybe in most Western countries, there's been a de-emphasis over the last 30 or 40 years of trade jobs. Everybody was told to go to college. That was really your best path to a good living. And of course, we found that not to be the case here, particularly in the last few years. And in fact, the trade jobs are among the highest paying jobs out there. And there's critical needs for people to do these types of work, working outdoors, exposed to the elements, exposed to inherent dangers that don't exist at an office job. So again, this is going to be an ongoing problem for a number of years, I suspect. Let's roll this little segment here from a news report about this topic.
With each blow of the hammer, much-needed housing is one step closer, but it's also one day closer to retirement for those doing the work.
We're in a perpetual shortage of workforce, and that's going to stay that way.
The demand for housing is up, but so are the costs. Materials more expensive, and so is labor. Over the past few months, the sector has lost 14,500 workers, a nearly 6% decline.
And again, I really do hope that someone performs a thorough third-party investigation as to the overall causes that led to this collapse. And I'm not talking about merely the technical or the construction-related issues. The broader topic, I think, in terms of a systems engineering analysis needs to be brought to bear as to what the implications are for adjacent buildings or for similar construction throughout the city. You know, in my opinion, it seems to me that people in general aren't very good at assessing risk. And engineers are often responsible for accounting for the appropriate level of risk. But again, in terms of formal education and even in practice, I don't think there's sufficient emphasis on this. I like to show this risk matrix because risk is a combination of severity and probability. So you could have a situation where something has a low probability of occurrence, but if it were to occur, the results would be quite severe or catastrophic even. So I think that really needs to be kept in mind on these types of projects, this type of construction. You know, if the view is that these are temporary excavations, they're not subject to permitting or city inspection, there may be gaps and not overlap in the design process between geotechnical engineers and structural engineers for the retaining wall. You know, I see this, I've had wall suppliers who have their own design staff for, say, mechanically stabilized earth walls. So they have these concrete facing panels that are connected to metal strips that go back into the slope that's backfilled to form a near vertical face for a retaining system so that you have more room to build whatever it is you're going to build at the base of the retaining wall. And their insurance company does not allow them to perform any geotechnical related design for these walls. They merely do the structural design. So they have to come to people like me to do the global stability analysis from a geotechnical perspective. So it may be that they can design the wall and yeah, the wall's stable, but if you look at the big picture, the overall slope may not be stable. So in the past, when I would take on those jobs, I'd always insist on including in my scope of services construction phase observations to make sure that they were in fact building the wall in a manner consistent with the design and consistent with my assumptions about the material being used and how it was being placed and so on. So also, if this were a permanent structure, it would no doubt be subject to the full building code requirements that includes designing for seismic loading. And in this area of the Pacific Northwest, in Vancouver in particular, the design values for ground acceleration from an earthquake are around 0.5 Gs, which is quite high. So I could see a situation where if you had a major earthquake event with these high ground accelerations, these walls that weren't designed for that seismicity apparently would be vulnerable to collapse. And if that occurred, you could lose infrastructure, utilities, roadways, even bridges. There was an elevated bridge nearby here to this site that failed here along North Road. You can have nearby high-rise development so that if an excavation collapses, you have ground loss and it affects the stability of adjacent buildings. So here's a concept that I only recently came across, and it's a concept related to behavioral science, and that is of the dialectic, that two seemingly opposite things can be true at the same time. And so in this context, the dialectic would be perhaps that you have this type of shotcrete retaining wall system with soil anchors commonly used throughout the region, and it's used quite extensively to reduce the costs associated with the development of such sites. But at the same time, there could be a high degree of risk that hasn't been appropriately assessed or the implications fully appreciated. So both things could be true at the same time. You know, I've only been to Vancouver a couple of times. The last time was over 30 years ago, and it was beautiful and very interesting city. And hopefully it's still like that. I mean, I imagine it must be because so many people are moving to the area. The development is, housing is quite expensive, and this retaining wall collapse occurred at a high-end development, I don't know that it's going to solve the housing problem if, these are multi-million-dollar units. But be that as it may, this is what we're seeing in major cities throughout the world, quite honestly, particularly in North America. We see it in San Francisco, New York, Miami. Speaking of San Francisco, I've done a number of videos on the Millennium Tower, where the original foundation design and construction did not involve full depth piling to bedrock. Instead, they were much shallower piling, which led to excessive building settlement and tilt far beyond what had been anticipated for the design. And again, looks like a combination of design errors, lack of proper permitting and oversight, and developer cost-saving measures. I also did a story about 161 Maiden Lane in New York, a high-rise residential building. It hasn't been completed. Nobody's living in the building because instead of full-depth piling, which is common for these sizes of buildings in the area, they elected to use ground stabilization. So jet grout, soil cement foundations, not driven piling, not drilled shafts. And reportedly, this building has experienced excessive tilt, and it's a quite slender building. So it's resulted in extended shutdown, and they're battling it out in the courts right now as to how this thing's going to progress. So talking about the governance, the city permitting and inspection side, I'm from the Kansas City area originally, and I grew up in Missouri. And around the late 80s and the 90s, there was a big construction boom in the city of Branson, Missouri. It became a real entertainment center for primarily families. So they were building amusement parks, hotels, entertainment venues. Various country music musicians had their own theaters named after them at these throughout the city. And it went from a small little town with I think a handful of inspectors that were accustomed to doing small commercial buildings and residential building inspection to this major commercial development practically overnight. And they simply weren't equipped to address mechanical, electrical, plumbing, fireproofing, a whole host of code issues. And then later, too, they realized that a lot of these buildings had been designed and built below what would be required for the design seismic loading as well. So these types of rapid increases in development can quickly overload the governance in a local area if people aren't careful. So this leads me to some questions here, and I'd be interested in hearing what questions you might have about this whole situation in Coquitlam. So one thing that occurs to me, and hopefully there will be an independent investigation as to the causes of this wall collapse. But first of all, was the retaining wall built as designed? A number of you pointed out that immediately prior to this wall failure, it looked like the anchor plates had pulled through the shotcrete wall facing. And you could see that here. You could actually see soil pouring through the openings left by these anchor plates before the collapse of the shotcrete wall facing. Also, a number of you pointed out as well that there appeared to be absolutely zero steel reinforcing in the shotcrete face of this wall. And if there was mesh, there wasn't very much. So that's something I'm curious about. Was it designed that way? And if it was not designed that way, does that mean that there was not adequate on-site inspection that would otherwise have noted such a discrepancy? Another question is, who was responsible for the design of the shotcrete retaining wall system? Was it a geotechnical engineer, a structural engineer, or both? Okay, another question is, was the retaining wall system properly designed? Was there a difference in actual on-site soil conditions relative to what may have been assumed for the design? And as a number of you have pointed out, the geology in this part of Vancouver is quite complex. You have glaciation, you have seismicity. It's very similar to other places in the Pacific Northwest, as well as California, where you have young, complex geology, and you can have a lot of variation, even locally, in on-site soil and rock conditions. And to me, this is one of the more important questions, and that is, will government regulations change to require such retaining wall systems to be more robust and subject to permitting and inspections by building officials? One of you made a comment that really these wall systems should be designed as if they're permanent walls in terms of their capacity for loading. And I understand that line of thinking. I mean, if they consider temporary excavation to be something that's going to be in place 1 or 2 years, that's actually long-term in terms of soil mechanics, in terms of drain versus undrained soil strength parameters, and in terms of the potential for degradation due to weathering, just other things going on, vibrations. And again, given the consequences of a potential failure to adjacent infrastructure, roadways, and buildings, as well as on-site safety, I think this may need to get seriously examined. And of course, the side pushing against such a requirement would be undoubtedly higher development costs in an area that's already very expensive. And just in general, I think part of the potential problem with projects like this is the separation between geotechnical engineering and structural engineering. And that's in part due to the high degree of specialization that's occurred in recent decades, particularly involving sophisticated computer analysis. But this wasn't always the case. I mean, you had essentially the people that developed geotechnical engineering, including Carl Tersaghi and Ralph Peck, who had extensive backgrounds in both soil and structural engineering. I had the opportunity to work with Dr. Peck in the late 80s, early 90s. He was brought in as a consultant on a embankment dam project I was working on. And he was a world-renowned consultant because he had a wealth of practical experience. And usually, you know, and one of the key aspects to the development of the field of geotechnical engineering was observation of prior failures and what had worked in the past. Essentially, they looked at what worked and then delved into what the soil and rock characteristics were for the size of the foundation and on those sites that worked well versus those that didn't. And so really the development of the soil parameters came on afterwards, observing things that had been built using, you know, what they call the observational method. Well, here we have observation of a retaining wall that collapsed, could have led to serious injury or loss of life, or impacts to pedestrians or drivers on the adjacent roadway. So I think it's quite possible that this type of construction may need a reset or certainly a careful review to make sure that everything is built the way it needs to be built to provide proper protection. But again, I'd be interested in your thoughts on this. Please leave me a comment. A lot of you have reached out to me. I've enjoyed that engagement. Also, check out the link in the description. I've compiled a list of the top civil engineering disasters from the last 100 years. Thanks for watching, and please stay tuned for future videos.